Hello and welcome to our virtual poster presentation. Today we are going to model this railway station here as a graph. But before we do that, let me tell you why. We are building a rail infrastructure knowledge graph system. In this knowledge graph, we integrate different kinds of rail data silos into one system. We have rail interlocking engineering data. On a network level, we have topology data as well to know how the stations are connected. And for the interlocking components themselves, we have some product data. Our goal is to build a system to represent this kind of rail infrastructure data to support several use cases during the engineering. We want to be able to run topological queries not only on the railway station data themselves, but we want to run this on the whole network data while having full access to the fine-grained engineering data of the individual stations. We want to be able to find stations where specific components are installed. And we also are interested in finding similar modeling patterns which are used frequently or in specific stations. Now, a first step when building this kind of systems is to have a common understanding of the relevant entities which are used. In the case for rail infrastructure, the most prominent ones are the tracks, the switches, and the signals, as well as the interlocking system which controls these. Now we went looking to find an ontology where this is represented in a way which is useful to us, but we didn't find any. So we have to create our own ontology. So let's start looking into our example. We have, similar to the poster, we have a main track here, we have a side track here, and an entering track on this side. We have a signal which is currently red and a train patiently waiting to drive into the railway station. Once the switch is set, the signal turns green and our train can go. We drive it to the siding track. Okay, all well now. So let's try to represent this part here as a graph. In the simplest possible way, we would just make this switch a node where the different tracks are edges coming in and going out. In this very simple model, we lose the information that the switch has kind of a direction. So while it is possible, the way that we saw, to go from this track to the side track, but also to the main track, it's not possible for the train to go directly from the siding track to the main track. And this information is not contained in our model anymore. So we didn't want to start from zero when creating our own model. So we looked into existing standards and modeling practices which are already there. You can find 3 of them on our poster. There is the component port model, there is the double vertex model, and there is the connexity graph, which is used by the rail topo model and in turn then by RailML again. In the end, we chose the RailML standard because it expresses the things that we need very well. The RailML standard is a data exchange standard based on XML, which allows to exchange, for example, rail infrastructure data and in the version 3 also interlocking data. So how would our little example look like in RailML? We turn things a bit around and we have nodes now for the tracks. These type of nodes are called net elements in RailML. So we have one net element for the incoming track, we have one for the main track, and we have one for the siding track. Now the switch itself doesn't get a node. Essentially, it gets 3 different nodes which are called net relations. These net relations connect the net elements that you see here as circles. So we have 3 net relations which connect our net elements. To be able to represent this knowledge that only these pairs of nodes, these pairs of tracks are navigable, the net relations have corresponding annotations. This net relation here will have an annotation which say that this part here, this relation, is not navigable. And in this way, we encode this information. The signal that we have here is then attached to the net element of this track. Please check the poster to see the complete representation as it's done in RailML. We are currently building this ontology together with the RailML community. So if you're interested to collaborate, please just send us an email. Thank you for watching and enjoy the conference.